Welcome to Lesson 32. In this lesson, we will discuss and practice writing Lewis electron dot diagrams for both ionic and covalent compounds. Let's go. Today, we are going to learn how to draw Lewis dot structures for both ionic and covalent compounds. You will learn how to draw the Lewis dot structure of ionic compounds in this video, and we will draw the Lewis dot structure of covalent compounds together in the classroom tomorrow. The most important thing to remember when drawing the Lewis dot structure of ionic compounds is to always begin with a correct ionic formula. Recall that the sum of oxidation states of all formulas must equal 0, like the oxidation states of the noble gas. This can be done if the positive ions have no electrons and the negative ions all have a complete valence shell. Make sure that our ions are drawn in brackets with the charge outside. And again, double check your work so that the sum of the oxidation states is 0. Let's try writing the ionic formulas for these compounds, beginning with sodium nitride. We know that sodium must have a charge of +1. If there are 3 sodiums, then nitrogen must have a charge of -3. Now let's put it together and draw the structure. Now pause the video and try to draw the Lewis dot structure of the 4 remaining compounds. Today we're going to discuss naming covalent compounds. Hi class, welcome to Lesson 8 of Unit 5. In this lesson, we'll discuss how to draw Lewis dot diagrams for covalent compounds. At this point, you should already be familiar with the naming and Lewis dot structures of ionic compounds that transfer electrons. Today, we'll focus on covalent compounds. When 2 nonmetals bond, they share their electrons, as they have very similar electronegativities. The attraction between the 2 atoms for a shared pair of electrons forms a covalent or molecular bond. Their electrons will form into one uniform electron cloud. Electrons will always be shared in pairs. Most atoms form bonds to obtain stable, noble gas, low energy electron configuration. That means a valence of 8, or sometimes 2. Here are a few Lewis dot diagrams. Now, you can see that typically one of the elements has 8 valence electrons. You can also see the hydrogen electrons has 2. Here, if I circle the electrons for each element, kind of form a Venn diagram, where the 2 circles intersect shows the electrons that are shared in the uniform electron cloud between the elements. Make sure you pause the video so that you can pause and write down the steps to drawing Lewis dot structures for covalent compounds. You should always begin by drawing the lone element, the element with no subscript, first in the center, with all of its valence dots. Connect the other elements on the outside or the periphery. You want to make them as far apart as possible, as they are carrying electrons, and electrons are negative and repel each other. Use lines to show bonds. Then, add the electrons for the peripheral or outside atoms so that they have the number of electrons needed to complete their valence shell. If any electrons are not in pairs, pair them up so that you can form a multiple bond. We will do some together, and then you can try some on your own. Let's begin by drawing the Lewis dot diagram of nitrogen triiodide. Notice how covalent compounds have prefixes in their names. We must identify the lone element. Since nitrogen does not have a subscript, nitrogen is the lone element. I'll begin with nitrogen, and then I'll draw its Lewis dots. The number of dots always equals the valence. Nitrogen is element number 7 and has a valence of 5. Don't forget, always dot the valence one side of your imaginary box at a time. Now I'm going to bond the iodine. I cannot bond iodine here, as these electrons are already paired up, but these electrons desire a pair, so I can bond the iodine in any of those positions. So I'm going to make 3 bonds for iodine and add in my iodines. Then I need to complete my valence of iodines. You can use dots, X's, or a combination thereof. So what I can see is the first valence electron for iodine is here on the line. I need to add 6 more, as iodine has a valence of 7. So 1, 2, 3, 4, 5, 6, 7. This step should be repeated for each iodine. Again, this dot or X here on the line represents the first valence of iodine, but iodine has a valence of 7. 1, 2, 3, 4. Remember that when dotting out, once you go in a complete revolution, you always jump over the bond line. 5, 6, 7. And one more time, our first dot is the line. 2, 3, 4, jump over the line. 5, 6, 7. So this is the Lewis dot diagram for nitrogen iodide. Let's neaten it up and put our final answer in the box. Now it is your turn to try carbon tetrabromide. I'll put the answer in the box. Did both of your structures come out at a right angle? They should have. If not, try again. Remember, you can only form bonds where there are lone electrons. Here we are going to address the next rule. If there is more than one lone electron after all the atoms have been connected, look for lone electrons that you can pair into a multiple bond. Let's try oxygen together. Oxygen is element number 8. Oxygen has 6 valence electrons. Let's dot it out. Oxygen has 2 positions to make a bond. It can make a bond here and here. You can bond your next oxygen anywhere you want. But since I read from left to right, I'll put it here to the side. So I'll draw a line at this lonely electron to represent my bond with the next oxygen. Then I'll draw in my next oxygen with its Lewis dots. Again, oxygen has 6 Lewis dots. The first Lewis dot is here on the line. 1, 2, 3, 4, always jump over the line, 5, 6. I have all the atoms I need, and I've bonded them together. But notice that here we have an unpaired electron, and here we have an unpaired electron. These electrons, since they're from two different elements, can come together to form a multiple bond. So all you'll need to do is erase and replace. So notice here, these two oxygen atoms share 4 electrons, or 2 pairs of electrons, in a double covalent bond.